All right, let's get going here with our next talk right on time. I just met you. We were expecting Lee Johnson, but he didn't make it. Your name is Felix?
Yes. Felix Schroeder.
Felix Schroeder. So welcome, Felix Schroeder, and Shaikh Ahmad. Sorry.
Thank you.
All right, take it away, please. You want two microphones?
Cool.
Good afternoon, everyone. How's everyone doing? Good? Had a good lunch? I saw those drumsticks and steaks were gone pretty quick. So, yeah, we can't be close. So, today we'll be talking about retrieval augmented generation and how can it help us enhance cybersecurity. And we will be actually going at it at a very high level because with the time we've been allotted, which is about 30 minutes, it's very hard to get into the core of it, which is the vector database system. But we'll be giving you a high-level overview, and the cool part is we actually have a prototype demo that we're working on, and we get to play with it towards the end of the presentation. So please, stay with us, and we'll take you through it. And my name is Shaikh Ahmad. I'm an IT project manager, and I have my colleague Felix Schroeder doing the presentation with me today. Our CTO Lee Jensen, he couldn't be here. So we're proxying on his behalf, so bear with us. So why this matters? Well, in order to begin, first, we all care about cybersecurity, and that's basically why you guys are here. We handle situations every day, if not every hour of our work life, and we do care about this. And another thing is, we've been talking about this overused word, artificial intelligence, in every community. And of course, there are a lot of benefits, and it's kind of magical to see it work and how it gets you a result within a matter of seconds, but it has its own limitations. And it doesn't really change it over time, or it doesn't update itself. You just get to use a version that was from like last year or the year before, and then you get basically a text response. So we'll be talking about some of those limitations throughout the presentation. And therefore, we also identified that for cybersecurity, since it's ever changing, we need a more situational and aware system to address the problem where we're dealing with incidents and security response. And the last part of it is hallucinations, and we'll be talking about it more, where like AI is more probabilistic, and it gives you a likely answer, but it doesn't care about whether that answer is accurate or not. So that's the biggest limitation that we try to resolve with the RAG system. Next slide, please.
All right. So let's begin. In 2023, we saw the release of large language models like ChatGPT and others, and these were fantastic. For the first time ever, you had a model that you could send it a question or text, and it would respond back to you in text, and it seemed to respond, based off of what you said, fairly accurately enough. And the way that it worked behind the scenes is that Chat and other models, LLMs, learn to study all of a huge corpus of English text, and it learned the relationship between different words and what different words mean in different contexts, and it's able to sort of use this to make an correct or an auto-predicting feature where it can look at the history and usage of these words in English and sort of intelligently pick what should come next based off of the context and information in the sentence. But it's important to realize that it picks what is the most likely answer in a given list. And what is the most likely answer isn't always what is correct. This is what's referred to as AI hallucinations, where the chatbot thinks that it's completely correct. It gives off some text. However, it is completely nonsense, and it's not based off of anything. And this might be why you've maybe tried to use ChatGPT. You ask it a question one time, and it responds one way, and then you ask it the exact same question in the exact same way, and it could respond a completely different way. This is because of that probabilistic model. And it really means that these systems are not completely reliable. If they are able to produce different answers and produce different answers that obviously are not correct, then how could this system be correct? And so this has been a huge problem. These are two famous examples that I at least just knew about just from knowing about it, where a lawyer used ChatGPT in a briefing, and all of the cases, or at least a lot of them, it just completely made them up. It wasn't based off of anything. And another example of hallucinations, Google used, tried to do a demo, and one of their bots hallucinated, and it ended up losing over $100 billion for their stock prices, which is kind of crazy that a flaw like this can have such a devastating impact. But this is a real issue that we need to solve, and it needs to be solved in order to make LLMs be able to actually be used and reliable. So how do we do this? That's why we have RAG, which is what I'm here to talk to you today about. RAG stands for Retrieval Augmented Generation. It is sort of the idea that before you have chat, or before you have any LLM answer question, you run some sort of query on this data that will go out and find the data that answers the question based off the user's question, and it finds the data, and then it returns that data directly to chat. So then chat is able to answer the user's question based off of the real-time data that it found. It's not just, answering the question, shooting from the hip, possibly making stuff up. It has its its source pulled up, it has its source, and it's literally reading the source, and a lot of the times regurgitating that information back to the user. So we'll run through an example. First, the user asks a question. In this example, it will be a zoology bot. What animal sleeps the most? The system can then take the user's question, and it needs to decide how it's going to, search for this information. It only has the text, which animal sleeps the most. So it can do this in a variety of ways. There are agentic RAG programs which pre-prompt the LLM and say, hey, here's a list of actions, here's a list of sources you can search. Which one makes the most sense for this context? And depending on how the AI responds, it will go out and get that source and get that text and then feed it to the actual bot, which will then read the text and answer it based on the text. Another important way of searching is semantic searching. This is particularly useful when you have to search a huge amount of documents. So AI scientists have, using the same kind of transformer model, they have found a way to map out all of human language as these vectors, multi-dimensional vectors. You think of a vector in 2D space, it's a point, a 3D space, it's a point in 3D space. These are 1,000-dimensional vectors that exist in 1,000-dimensional space, but the AI is able to build relationships and make these vectors so that words that are semantically similar to each other and words that mean similar things show up to each other in this vector space. And so we can then use that to numerically compute how similar to like a user's question is to, say, a data source. And so we can then use that to pick out the exact data source that the user's question mentions. So for example, in our question, what animal sleeps the most, it would compare it to all the different data in the data set. So maybe there's information about dogs, information about cats, but it would be able to semantically compare it, and because the vector for which animal sleeps the most corresponds with the information about koalas sleeping the most, it is able to then match that. And I think that this is also pretty cool to see, because you can see that the text doesn't necessarily have to match spot on. It doesn't necessarily have to be a direct keyword matching. It's just that they are semantically similar. The AI has found how to make that connection and how to connect those texts. and return back the correct result. And after the chat is able to read back the result, it's able to give a response in natural text that sounds like a human, it behaves like a human, and is able to answer the question. And it can cite its sources based off of the exact source that we got. So it's extremely accurate, reliable, fast, and cost effective. And so this ended up being what we use.
All right, so now we'll talk about like the augmented generation a little bit, and I think Felix covered it really well. So the way it works is it injects the data in the vector model first. And then the vector database, anytime the user asks a question, it basically tells, this is the document, you need to answer the question, and then it goes to OpenAI and the chat model to refine that answer. So what's happening here is like, how many of you are working with like a state agency or like city, county? Raise a hand. Great, so we have a few folks. So for example, you're looking for like city codes or something that's very specific, or maybe like a law that just came out. So you would basically have that information within your data bank and the vector database. So what happens is when it's handing it off to ChatGPT, it will tell like, this is the question my user need to be answered, and here's the document you're gonna use. So that way you actually get a more grounded answer to your question. And then coming back to the big word like cybersecurity, like how do we relate it to that? So basically when you're doing like threat response, you have to come up with reports pretty like frequently and pretty quick. And when you have those definitions and like say for example the standards you use already within the data bank of the vector database, which you can update pretty easily, then you can get a more refined answer rather than it trying to get definitions from 1925 and then give you like a response report on that. So can you go back to the next one? Previous one, sorry. So basically the RAG outputs, how is it different? The question is like, why do you need RAG? Because you have ChatGPT, it's free, like, or it's not actually, we just don't know it yet. So we'll end up paying for it, one way or the other. So basically, it is more grounded and verifiable. So when you're asking a question, it's gonna actually give you the exact source. It's like, this is my answer, this is what happened, and here's the source. So feel free to click on that source, and then you'll see that more on the demo we'll have at the end. And so is it coherent and logical or safe? So all these things actually, the three at the bottom are taken care of by OpenAI or the chatbot you're using, because it usually, if you give it the right context, it comes up with accurate content. So what I basically wanted to emphasize on is like when you're interacting with OpenAI, it can help you a lot with the content, but it just can't do the context for you. So what we're doing, here basically through RAG and the vector database is providing that additional context so that it comes up with a more relevant answer, not just like a internet search. So how does it really impacts the industry? So here are some things that we think that it should be able to help with off the gate is like threat intelligence summarization. So if you already have your definitions, for example, if you use like the NIST ISO 27001 or NIST CSF, those definitions can be pre-uploaded, and it will actually you can code it to actually say, use this code definition or these threat responses to come up with the response. And then it will use exactly those definitions or advisories to come up with the response. And then also it will have those like the NIST, ISO, and compliance checks built in place. So the demo we have basically have a bunch of public documents that we can ask and query through. But then these are some of the cybersecurity implications of RAG that could be very beneficial. And then security operations chatbots, like how many of you like use those, if you're not sure what you need, ask a question on websites. So yeah, I'm sure you guys use it a lot. So what it does is, in some ways they use a widget. So the widget just goes like, it sends a question to OpenAI or like, ChatGPT, whatever model they're using, and they just come up with an answer. But with RAG, you can actually say, these are the 20 documents that are relevant for my website or my state agency or my company. So anytime you answer a question, make sure you go through this. So it basically automatically does that every time, so you have a more refined and accurate result. So some of the benefits of using the RAG instead of the large LLM, where you can still do this, is it reduces the token usage. So basically, anytime you're using like a paid version of GPT, it has a like token limits, and you have to pay for them. Although they cost probably like 1/10 of a cent per query, but over time it accumulates. For example, if you're running like an archive agency where people search for stuff like thousands or like 10,000s per day, then this cost may become significant over time. And like our model actually helps kind of mitigating that a little bit. And then the snippet level filtering. So instead of say looking at a billions of documents, it's basically giving you the definition, like this is the document, here's a question, go to OpenAI, refine an answer, and give it to me. So and we'll see that in action in a little bit. And then also sometimes when you have like constrained hardwares, which is often true for like state and city and county governments, it can be a little bit faster compared to the GPT model. And some of the benefits is like, as you see over here, is like the real-time info. So what RAG does is like, you can every morning like upload a few documents to your OneDrive or your shared drive and say, this is the new definition for today. So it's pretty relevant and up to date. It's not really using old information. And then the hallucination risk is pretty low in the RAG model because it's dealing with real-time data. And then compliance help is automated, so once you have your definitions and you upload them and you actually code it to use it every time, you don't really have to do anything. You don't have to say like use NIST 27001 or sorry, ISO 27001 every time you come up with an answer. So the next one. So here we will get into the demo, and we have a few modules within the demo here, and then Felix will help us with that. So we have a file and image search, and we have document summarization. So what we did is the system has some pre-prompted questions already, but we can also ask some questions from the audience, see what it comes up with. And also, it's important to keep in mind this, it is a work in progress, it's not a finished product yet. We are trying to get more feedback and refine it as we go.
So I'm driving this demo over here. I'm going to start off with the New Mexico Tax and Rev public documents. So these are just public documents that are available that you can learn about, that you can use to find information on taxes and stuff. So I have a few sample questions, but we can also ask whatever questions we want. How do I file my taxes electronically? You can see it's going in, it's searching, and it's very fast. It found its sources, and the LLM was able to answer it. And so you can see it gives a response, but not only does it give a response, but it comes back with sources that it used. And these are actual PDFs. If I was logged in, I could view the file. But you can see here, it cites it from the real documents, and it includes scores and thresholds, and the chat is able to use this to more correctly give its responses. And you can see the chat's able to cite its sources within the prompt itself. And it's even able to do spelling mistakes. For example, brackets is not spelled correctly in this question. That was not on purpose, or that was on purpose. I swear I can spell, but you can see even though brackets was spelled incorrectly, it still was able to pick out what it needs to and respond correctly. So that's pretty cool.
So in the back, are you guys able to see the screen, or you want me to kind of read you some of the questions? It's good? Yeah, I see some thumbs up. So yeah, basically, and let's take a question from the audience related to New Mexico tax, see what it does with the documents. Any questions? I know you have a lot when you go to your tax advisors.
When does the VA healthcare tax exemption take effect?
Uh-oh. tax, VA, healthcare tax exemption take effect?
Property tax.
Oh, sorry.
The-
Property tax?
Correct.
When does the property tax?
Exemption take effect.
I should also say that this has not been trained on most recent documents. I think this is from documents back in November, so it might not include.
So one of the main things about this, model is that if it doesn't have the right document, it will actually tell you like, I don't have it. And then, the way we're actually designing it is then you can say like, okay, go to ChatGPT, like OpenAI, like find like whatever is there like publicly available. And these ones are actually pretty like grounded specific documents, and as Felix mentioned, since we haven't uploaded it in the database, what
Yeah.
it's saying is this information is not within the system yet. But there's a way like you can override this and still say like, I want the ChatGPT answer. Does that help? Any other questions? Yes?
You haven't looked, like, you haven't compared across documents to, for example, say, look for any incongruities among the sources you would have available to you?
I can't hear that. Well, sorry.
Sorry, basically, can you tell her, like, look for tax documents that are contradictory to other tax documents in your source data?
Okay, so
So yes, you are able to have it compare documents, and a lot of the times with the current RAG model, it will compare the top 5 documents that were semantically similar. But I've also had to work with some other AI where it will do a, I'll give you an example. We had road documents that are all semantically similar, so this semantic search wouldn't have really worked well with trying to search through all those different road documents, because if you would have asked it about, who's responsible for this road, it would have been very semantically similar to questions across the, documents across the board. So what we ended up doing is we had ChatGPT read all the documents and create summaries of those documents that would specifically look for whatever, maybe incongruities that we're looking for. So in our case, we looked for who was responsible in each document, and so it would just extract that specific information about each document, and then we could build a chatbot that could then respond to that information. So with more of that kind of aggregated data, you do have to do a lot more pre-processing, but it is possible to do.
any more questions? So the next segment we have is the image search. So we want to kind of demo it real quick. We want to give you a quick overview of it. And because of the fact that we're not logged onto the system, it doesn't work that well here. And so,
Yeah, it doesn't work.
yeah. But if you go down to the summary, we want to just talk about the basic summary, or the generic one.
So, other things that we were working on are potential ways of image searching, and it doesn't work here right now, but we had another demo where you could search for images of green chili, and it would come up based off of a similar sort of clip. It used the clip model, which is basically a way of doing that vector embedding stuff, but with images. But another cool thing about the image text is you could also prompt ChatGPT to create a description of the image and then embed that too. So that's just another way you could search for images. These models are able to create pretty good and pretty descriptive descriptions of these images, as you can see here.
So just to add to that, like similar to what we do with text, you can also use like vector, your images, and kind of use those data. And if you go, can you click on the slider? So basically the description you're seeing is basically a more comprehensive one, but if you ask ChatGPT without the vector database, then it will give you an answer like this, which is very generic. But when we do have the other description, if we go back to that, then it gives you exactly where that is, and it basically recognizes characters and landmarks. So it's also pretty cool. Like for example, let's say you're in the tourism department and you want people to find like specific images, then this can really help you. You can kind of refine that data bank quite well for them to use. Any other questions? How are we doing on time? Are we ahead?
5 more minutes.
Oh, 5 more minutes. More questions? Any feedback on the database and what we have covered? Would really appreciate it. Yes?
I'm just wondering, what other data sets do you plan on incorporating?
So basically, for data sets, it depends on, like, say, state agencies. Like, I mean, we can technically take, like, all of the New Mexico governor's document and just embed it within the vector database. It's basically on demand. Let's say we have a project with the healthcare authority, then we will ask them, like, okay, this is your data bank. We actually have our file management system, so we have a storage for that. So what we can ask them is, like, which documents do you want? So they'll give us, like, a list of 10,000 PDFs. So we'll then recognize whether we will need, like, OCR or is it going to be working. Then we try to convert those 10,000 documents to the vector database, and then we give them their own tailored database and the system to actually work with. So in terms of, like, government agency use, it kind of, like, saves time a little bit, because sometimes, say, you're working in the legal profession, you need, like, exact answers. You don't want it to hallucinate and give you court cases that it imagines happened. Yes?
I've got another question, but with a microphone now. It seems like you're mostly applying this to the public sector. And I'm just kind of thinking, in my job role, there are times, so I don't work in the public sector, but there are times where I am trying to get someone to secure some computer for XYZ reason. And I want to look for a policy within a ton of different policy sets. Do you have any plans to expand this to the private sector?
Yeah, definitely. So, to be frank, we're not a cybersecurity company. We're like generic IT. So it's very difficult or challenging for us to kind of, like, pivot from that to, like, cybersecurity all of a sudden. But this is actually, like, I want to say, a step in that direction. So we are exploring. And then I think the factors we talked about, like cybersecurity today, are kind of important. Like, for example, if you have the standard definitions or advisory already in your data bank, then anybody in your team can access, like, ask a question, but they'll get that answer based off of the advisories. So they have the most relevant information. And we do have plans, but, let's say that we're not at the place to make these decisions. Any other questions? No? Well, thank you very much. And I just wanted you guys to kind of, I guess, give a hand for Felix. He's only like 17?
I'm
20.
20.
Okay, so younger than, but anyway, so he's actually our intern, and he's done a wonderful job. He's the main developer behind this, in association with our CTO, of course. So he has done a tremendous job at the company, and at his age doing this presentation, I feel like it's awesome. So give him a hand. Thank you so much.
It gives me hope, right? Hope for the future that we have smart young people helping us out. Thank you for that. And also, I would just say thank you to Shaikh for all the efforts and volunteering and organizing this conference. So thank you. Yes, please give him a round of applause. All right, we're going to switch over the computer and get the slides up for our next speaker. While we do that, make sure we're good to go. We'll be right back in just a moment.